Hello and welcome to this tutorial. The tutorial is titled How to Test Hypotheses using t-test and Mann-Whitney U test in STATA. My name is Maxwell Duapele. In this video, you are going to learn the difference between t-test and Mann-Whitney U test. You will learn how to check assumptions, that is normality and equal variances. You will learn how to perform t-test for comparing means. You will learn how to use Mann-Whitney U test for non-normal data. You will learn also how to interpret your results, that is the p-values, the confidence intervals and outputs. And finally, you will learn how to save and export your results for the purpose of reporting. Now, if today I open it and the working directory is set. So next, I just type this comment, call the data into STATA. Okay, and then to do that, we say use. The name of the data is combined data.dta, and click to enter. Okay, once that is hit, you can see over here that the variable names have appeared, showing that the data has been imported. You can quickly browse it by typing browse, and then our data is here. So let's continue. Now we are going to take a look at hypothesis testing, and we are going to do that using two different methods. The first is the t-test. Now t-test compares the means of two groups to determine if there is a significant difference between the two means, and there are three key assumptions. The first is that the data is expected to be normal. It must be normally distributed. Second is that the variance between the groups are equal. And third, the observations must be independent. For you to be able to perform a t-test, recall that I said that the data must be normally distributed. In order to be sure that the data is normally distributed, there's no any other way to do it other than to test for normality. And there are two ways you can do that. The first is the visual form, that is to use the histogram format, and which is to type out histogram and then the variable, for example monthly income, and then give the title to it. Of course, include the command normal so that the normality line will show, as well as the title, which is this. Now when we hit on enter and run the code, wait out for it in a few seconds, you can see that this is the title that we gave it earlier, and we can see that this is the normality test normality curve. The histogram, the bars of the histogram are not indicating any form of normality, and so that is one way to check whether your data is normal. Then we can also check for it using the Shapiro-Wilk test for normality. The code S-Wilk and then the variable, and hit on enter. Now the analysis for Shapiro-Wilk has been performed. What we need to do now is to go ahead and view what we have. Showing that there are 360,060 observations. This is the Wilk value, the p-value, the z-value, and so forth. If the probability value is indicating a 0.0 anything greater than equal to or greater than 0.05, that means that our data is normal. However, in this case, the probability value shows that it is 0.00000 up to the fifth place, which means this probability value is less than 0.05. Hence, our data is not a normal data. Recall that we mentioned that there are three basic assumptions that must be fulfilled in order for us to be able to run a t-test. The first being what we just finished testing, which is that the data must be normal, and then the next is that the variance between the two groups are equal. So now we're going to test for the equality of variance, and to do that we only need to enter the code rob bar for monthly income. Okay, rob bar for monthly income by sex. Okay, I'll write this two space here, and then run the code. So wait for it. Is that if the p-value is less than or equal to 0.05, we say that the variances are not equal. But if the p-value is greater than 0.05, as we're seeing in this case, these are the p-values, it means that the variances are equal. So the first normality test that we did showed that this data failed that normality test, but in this second case, it passed the test for. Now we are still going to perform the t-test just in case you encounter data that is normally distributed in the future. Recall that this one we're dealing with here is not normally distributed according to the Shapiro-Wilk test and the histogram test that we perform on it. So if you encounter a data that is normally distributed in the future, this is how you will run the t-test analysis. You type in t-test as a command, and then the variable is written by comma and say by sex, for instance, because sex is a binary variable, meaning that it is a two-group variable, and you run your code. When you run your code, this is the summary of the t-test analysis. As you can see, all those stuff that you have here. What is of interest to us is the fact that we check out all the p-values. In this case, we have 0.5, this is 0.8, and this is 0.4. All these p-values are greater than 0.05, in which case the interpretation is that we would have accepted that there is a significant difference. They would have accepted the hypothesis that states that there is a significant difference between the mean monthly income of male farmers and female farmers. Conversely, if the p-value was to be found to be less than 0.05, we would have rejected the null hypothesis and conclude that there is a significant difference. If you are enjoying this video, please leave me a comment, leave me a like, and share with your friends. Now, remember that in this data set, we found that the data was not normally distributed, which means that it did not satisfy the assumption or the use of t-test. So therefore, we will now have to defer to the non-parametric test which is called Mann-Whitney U test. So to perform that, simply to type the command rank sum monthly income by sex. Okay, monthly income by sex. Remove this space in case it causes trouble, and then run the analysis. Again, the probability value, as you can see here, is 0.8471, which happens to be in tandem with one of these. This is indicative of the fact that the p-value obtained here is greater than 0.05. No significant difference between the monthly incomes of male and female farmers as far as this data set is concerned. Thank you for watching. Please subscribe and God bless you. See you on the next one.